Okay guys, so today we are going to learn about the calculation of problem of internal statically indeterminate truss. So okay, this is an example that we can see that classify the trusses below, determine the internal forces, the modulus of elasticity of each member is constant. So we can see that for step 1 we need to do the truss classification, where we need to determine it is statically indeterminate or determinate, and if indeterminate, then what is the, it is external or internal indeterminate. Okay, so we can see that the member we have 10, which is 1 2 3 4 5 6 7 8 9 and 10. And then the joint we have 6, which is 1 2 3 4 5 6. And then the reaction we have 1 2 3, so we have 3. So m equal to 2j minus 3, so we get 10 is greater than 9, and the reaction is 3. Man, this is internal statically indeterminate, means that we can use the equilibrium system to calculate the reaction force for A and D, but then we cannot get the equilibrium system using that. So what we need to do is we need to use this method, okay, virtual work method. Then this is step 2, the truss is internal statically indeterminate, so we need to reduce one member, either BE or CF, so means either BE or either CF. So for this example we reduce the member of CF. Okay, so step number 2, okay, we close this first. Step number 2, we need to calculate the reaction force for support VA, HA and also VD. So from the calculation we can see that as usual we calculate the total moment A equal to 0, we can get VD equal to 20 kilonewton. Okay, and then we calculate the total Fy to 0, then we get VA equal to 15 kilonewtons. So after that we need to calculate the real forces F for each trusses. So as here I already marked the step 1 2 3 4 5 and 6. So this is the joint method, the alternative joint method that I use to calculate to obtain the internal forces for each member. So we can see that we can start from A, and then we put this value of 15 kilonewton, the force. Okay, so we calculate this, we get 15 and 15, then this is 15 also. So also the same method we repeat for all other joints. And then this method I will not say much here because this is same as the previous chapter, so you can refer to previous chapter calculations. Okay, after we obtain this, then we'll go back to calculate the reaction force for support A and D due to the virtual force 1 kilonewton at member CF. So from the calculations we can see that we use the same method, the total MA equal to 0, we get VD equal to 0 here, and then total Fy equal to 0, then we get VA also is 0 here. So you can do the calculations also and then double check this, is it correct, and then okay, so you get VA and VD both is 0. Okay, so next step now is we need to calculate the virtual forces U for the internal forces caused by the vertical virtual unit load 1 kilonewton. Okay, so from this calculation we input this the A and D, the support, the reaction is 0 and 0. Then we start from here, we get the calculation here is 0 0, and then for point D here is 0 and here is 0. Then we continue with point F, point B, point E and point C, then you will get these calculations. Okay, you can do the calculations also at home, so you can try this. Okay, so after that we calculate this, we complete both real forces and also virtual forces, then we can start to make the table. So for this table you can see that we need to input the value of length, area, and then length over area, and then we input the real forces from the calculations for each members, and then the virtual forces for each member, and then we may make the calculation of F U L over A and U power of 2 L over A. Okay, here we didn't put the E because in the equation they mentioned that E is constant, so E is constant. Okay, and after that we get the sum of FUL over A and U power of 2L over A, then we can get the value of x. The value of x is equal to negative total of FUL over AE over total of U power of 2L over AE. So after you get this calculation, you can see that you get 2.16 kilonewton in tension because the value is positive. So after that we calculate this, then we need to get the calculation of XU. XU is the value of x times the calculation of virtual force. So we can see that the first value you get 0 times 2.16 you get 0, 2.16 and you get 0, sorry. And then negative 0.707 you times 2.16 you get negative 1.53, and then you calculate all of this, you will get each value of XU. So this value of x is equal to the real force plus the XU value. So you will get this 15 kilonewton from 15 plus 0, and 15 plus negative 1.53 you will get 13.47, and then 20 plus 0 you get 20, and also the same you repeat. Okay, so after that calculate all of this, then you can draw again the internal forces for all members and input into the truss again. So you can see that the reaction force is 15 and 20 from the calculation, and the F, the final F, the internal force for each member, is from the table just now. So you can input the value with the angle of the direction to show it is in tension or in compression. Then you input all of this, then you complete this example. So I hope you guys enjoy and understand this example. So please try at home. Thank you. Bye bye.